going, let's take a look at this limit today. In this video, we are going to find this limit in 5 different ways. And the first way is what we usually call the conjugate method, which is done by multiplying the numerator and the denominator by the conjugate. And the first thing that we should do when we try to compute a limit is that we can try to just directly plug in the 4 and see if we are able to just find the limit directly. And we are getting in determinate form, so I'm not going to show that here because you plug in the 4 plus 5, you get square root of 9, which is 3 minus 3, we're just going to get 0 at the top, and then also plug in the 4 here, in the bottom is also approaching 0. So we're getting 0 over 0, so we cannot just write down the answer immediately. So what we can do is that we can do it. The first way is that we are going to just take the numerator, okay, and then we multiply the numerator by the conjugate of the numerator, which is the square root of x plus 5, and then now we change the sign in the middle, so it becomes plus, and then we have the 3 here. So that is this expression here is the conjugate of our original numerator. And so what happens is that for the denominator, because we multiply the numerator by this expression, so we got to do the same thing to the denominator so that we are not changing the original function. So we need parentheses, and we are going to have the same thing. So square root of x plus 5 and then plus 3. And so now that is our first step. And then what we need to do next is that we just multiply the numerator out. Okay, so we are going to multiply everything out in the numerator. And so what we are going to do is that we can see that this is an expression multiplied to its conjugate. And so what really happens is that if we just recall something here, and so if we have a minus b and then times a plus b, and that is really just the difference of 2 squares, so we get a squared minus b squared, right? And so what happens is that we just need to identify the a and then identify the b, and then we can actually just square each one and then subtract them. And so what happens is that the a is our first term here, the square root of x plus 5, and then the b is the 3. And then, so we have a minus b, so we have square root of x plus 5 minus 3, and then a plus b is square root of x plus 5 plus 3. And so now we square the a, square the square root of x plus 5, so we just get x plus 5, and then minus, okay, so there was the minus sign, and then the b is just the 3, right? So we're just going to square it, so we get 9. So we get x plus 5, and then minus, the minus sign comes from here, and then we get the 9. And then now, what about the denominator? The denominator, we actually should just leave it as it is. So we should not be multiplying it out, because you can see in the next step that we are going to get something to cancel. So we are not going to multiply that out. So now let's just copy it down here. And so now we can simplify this expression right here. If we simplify, we have plus 5 and then negative 9, right? So we actually can write this as what? X minus 4. And you can see that that's why we are not multiplying out the denominator, because now we can cancel the top and the bottom. Okay, so we can cancel them. So we can cancel the x minus 4, so now they both become 1. And so what happens here is that the numerator becomes just 1, as you can see. And then now this becomes 1, so now we only have this expression as the denominator. So we are going to get x plus 5, and then we have plus 3. Okay, so just this expression now. And so now we are not going to get an indeterminate form anymore, because we have the numerator just a 1 here, so we can directly plug the 4 into the x. So we can just plug that into the x directly. So we are going to get what? We are going to get 1 over, okay, so we are going to get just 1 over the square root of 4, because we are replacing the x by the 4, and then plus the 5, and then plus the 3. So now we are going to get 1 over, and what do we get here? We get 4 plus 5, we get the 9 inside the square root, so we get 9 inside the square root plus 3, and then we are going to just continue with the calculation. So we have what? This is square root of 9, so we get 3 plus 3, so we are going to just get 1 over 6. So that is the answer. Okay, so next we are going to try to find the limit with a different way. Okay, now the second method for finding this limit is that it's actually quite similar to the first one. We are still going to use the difference of two squares formula, but we are going to do it differently. Okay, so what we're going to do is that we are going to factor the denominator. And then you may say, how do we do that? We'll see that in a minute. And so now for the numerator, we are going to just leave it as it is. So we have the square root of x plus 5. And then minus 3, so we are not going to change anything for the numerator. And then now what happens in the denominator is that based on the what we see in the numerator, we are going to modify the look of this expression. So it's still going to be the same expression. So what we're going to do is that we are going to just add a 5. So we have x plus 5, and then you may say, but that's not even the same thing as that one because we haven't finished writing this expression down yet. So now there was still a -4 there, so just leave it. So this x I just copy, the -4 I just copy. Okay, now I'm adding the 5, and then that's changing the problem, so we need to subtract the 5 back. Okay, and then so what we're going to do is that we are going to keep this x plus 5 here, so we just need to compute the other two terms. So we have -4, -5, so we are going to get -9. So now our function becomes x plus 5. And then what do we get here? We get -9. Okay, so x plus 5 minus 9. Now, what happens is that we can write this as, let me use the same color. So now we can actually write this one as x plus 5 and then write it as a square root and then square. So you can see that if we square that square root, we'll just get back to whatever that we have inside. So it will be the same thing as the x plus 5. And then what about the other thing? The other thing is the 9, right? So the 9 is going to be what? We can actually write it as 3 square. Okay, so actually, we can put parentheses around the 3, so we have the square on the outside. So you can see that this is the difference of two squares. And so now let's just recall that. So if we recall that we have something square minus something else square. Okay, so the first is A, and then the second blank is the B. And so now that can be factored as what? A plus B, A minus B. So we have plus and then we have minus. So we have A here, then A here, and then B here, and B here. Okay, so now what is A? A is actually this expression right here inside the square. So what do we get here? We have the square root of x plus 5. What about the B? The B is the 3, as you can see. So now we can actually factor the denominator. So we are going to get, okay, so the numerator we still just copy. The denominator is that we have A plus B, so A, and then plus, and then B. B is 3, so we just get the 3 here. Yeah, so don't include the square, right? There is a square here, but we are not going to include that. And then now, what about the other factor? It's A minus B, so we are going to get square root of x plus 5, and then minus the 3. Then so I need to just draw a longer fraction line here, so now that looks better. Okay, so as you can see that we have the square root of x plus 5 minus 3, and then same thing right here, so now we can cancel them. So after canceling them, then we are now left with just this expression in the denominator. So our limit problem becomes 1 over the square root of x plus 5, and then plus 3, and then that's in the denominator. So now we can directly substitute the 4 into the x here, and we are still going to get the same thing as you can see in the when we did it with a different method earlier. So we get what? This is just 3, right? So we have 1 over 3 plus 3, so we are just going to get 6. So 1 over 6. And then next, we are going to use another method to find this limit. Okay, the third way to find this limit is to use L'Hopital's rule. This may be the fastest way to do it because taking the derivative is relatively simpler for compared to the previous 2 ways because we get relatively simple numerator in the denominator. Okay, so now as you already have seen in the first way that we checked that we plug in the 4, we get the indeterminate form of 0 over 0, right? So we get 0 over 0, so we can use L'Hopital's rule. So if we use L'Hopital's rule, we are going to take the derivative of the numerator and the denominator separately. Okay, so now looking at this, square root of x plus 5, which is actually, well, first, the square root of x plus 5, we can actually just write it as x plus 5 and then raise to the 1/2 power. So we can use the general power rule to take the derivative for this function. So we are going to get, what is that? We have 1 over 2, okay? And then what do we get here? We get x plus 5 to the negative 1/2. And then multiply by the derivative of the inside. The derivative of the inside is just 1, so we just leave it. And then take the derivative of the minus 3. This is a constant, so we are going to just get 0. So now our numerator's derivative, it's just this expression. What about the denominator? The denominator is a linear expression, so it's also really simple to take the derivative. The derivative of x is 1, and then the derivative of negative 4 is 0, so we just get 1. So now we have a function that is actually quite simple. If we just look at it, and then we can actually rewrite this expression so that we don't have a negative exponent anymore. And then so there was a 1/2, so the 2 goes to the bottom, okay? And then the 1 goes on top. And then now this x plus 5 to the negative 1/2, right? So we have a negative exponent, so we can move it to the bottom, and then we are going to get the square root of x plus 5. And then so that is the expression right here. And so now what can we do? We can actually, again, we can plug the 4 into the x now because we do not have the indeterminate form anymore. So we are going to get, oh, actually no more limit notation here, so we are going to get what? We have 2 and then the square root of 4 plus 5. And then so we have what? We have 1 over, then the 2 on the outside, and then the square root of, that is square root of 9. And then square root of 9 is 3, so we get 2 times 3. So our final answer, again, is 1 over 6. And so that feels faster than the previous 2 ways. What do you think? Now let's look at a different way to do it. Okay, now the fourth way is that we are going to use the limit definition of derivative. So the first thing that we're going to do is to recall the definition. So let's recall. Okay, so if we want to find, let's say we have a function f of x, and then if we want to find the derivative of that function f prime evaluated at a point, then what really happens is that we are going to have the limit as x approaching a, and then in the numerator we have f of x minus f of a all over x minus a. Okay, so now what we can do is that we can just take a look at what the function is and also what a is, because as you can see that there is the x approaching the a. So now what we can say is that we can say that if f of x is equal to the square root of x plus 5, okay, so that is our function, which is this part right here, and then and this a. Now, you may say, how do we determine the a? If you just look at this here, x is approaching a, and then we have x is approaching 4, so now we can actually say that, okay, so let's try that a is 4. So x is approaching a, x is approaching the 4. And then what happens? Then what really happens is that then f of this a, so we have this a right here. And then, so we plug the 4 into the function. So what do we get here? We get the square root of something plus 5. What is that something? That something is 4. So we are going to get the square root of 4 plus 5. So we get the square root of 9, which is what? Which is 3. And that actually just gives us this thing, as you can see here. So what really happens is that we are going to try to match this limit with this expression right here. So, and then you may say, how does that work? Well, let's copy down this limit here first. So we have x approaching the 4, and then we have the square root of x plus 5, and then minus 3, and then all over, and then we have x minus 4, right? So now what really happens is that we can try to match it. So you can see that the limit, and what is that? X is approaching 4, so 4 is really just the same thing as a. And when we plug the 4 into our function, what happens is that we have f of a here. So this 3 right here, this is f of a, as you can see. What about this? This one is really just the original function, so this thing is f of x. And as you can see that the numerator, we are actually just getting f of x minus, which is the same thing here, and then the 3, which is f of a. And so we have f of x minus f of a in the numerator. What about the denominator? The denominator is x minus a, so we have x minus the what? The 4, which is x minus a. So see that this is actually exactly what we have here. And that is equal to what? That is actually our what? Our derivative evaluated at a. So we have f prime of, what is that? That is 4, because a is 4. And so we have f prime of 4. Now we already know what f is, and all we need to do now is to find f prime and then plug in the 4. So all we need to do is that now we have what? F prime of x. We take the derivative, so we are going to get 1/2 and then x plus 5 to raised to the negative 1/2. And then so now what really happens next is that we plug the 4 in there. We plug the 4 into here. And so what do we get? We get 1/2. And then we have 4 plus 5 to the negative 1/2. And then so let's continue with the calculation. So we are going to get 1/2, and then this is 9. So 9 raised to the negative 1/2 power. So we get 1/2. What is the 9 to the negative 1/2 power? That is 1/3, because you have the negative exponent, so it's being moved to the denominator. And then take the square root of 9, we get 3, so we are still going to get 1/6. Okay, and then next we are going to have the another method, the fifth way of finding this limit. Okay, last way of finding this limit in this video, which is to use the Taylor series to find this limit. So what we are going to do is that we are going to first consider this square root of x plus 5. And so we have the square root of x plus 5. We can write it as x plus 5 and then quantity raised to the 1/2 power. Okay, so now what we're going to do is that we are going to find a Taylor series expansion for this function. We are going to center that at 4 because x is approaching 4. So we are going to, well, first we gotta take the derivative first. So we are going to find f prime, which is 1/2, and then x plus 5 to the negative 1/2. Okay, so that is f prime, and then f double prime is that we are going to have 1/2 and then bring down this negative 1/2 here. So we get negative 1/2, and then we have x plus 5 and then raised to the negative, what is that, 3/2. Okay, so now that is f double prime, and then we can actually just continue. So now we have up to the second derivative. We don't really actually need that many terms, as you can see later. So now what we are going to do is that because we are going to center that at 4, so we are going to plug the 4 into all those functions. So we have f of 4, so we plug the 4 in here. And then what we are going to do is that we are going to get, what is that? That is going to be 4. And then plus 5 to the 1/2. And then as you can see that that's 9. And then square root of 9 is just 3. So we get 3 over here. Then now the next one, f prime of 4. What is that? That is going to be 1/2 and then times what? 4 plus 5 raised to the negative 1/2. And so as you can see that we have the 4 here. So now what happens is that we are going to get 4 plus 5, which is this is 1/2, and then that is in the denominator because of the negative exponent. So we are going to get the square root of 9 in the denominator. So we have 1 square root of 9. And what is that? That is 1/2 times 1/3, which is what? 1/6. Okay, so that's 1/6 here. And then now continue. So we have f double prime of 4. And then, so what do we get here? We are going to get negative 1/4. Okay, as you can see here, 1/2 times negative 1/2. And then this one is still the same thing. So we plug the 4 in there. So we have 4 plus 5 raised to the negative 3/2. And what is that? That is negative 1/4. And then we have 9 raised to the negative 3/2, which can be written as negative 1/4. And then times this one is 1/9 raised to 3/2. Okay, and so we have negative 1/4. Then what is this? This is you can see that in the denominator of the exponent, that's a 2. So we take the square root of the 9, so we get 3. So we actually we'll get 1/3 to the third power. So we have negative 1/4 times 1/27. So we are going to get negative 1/108. Okay, so again, we can actually continue with more terms here, but we actually don't need that. Okay, so now we can actually start writing the series for this. So we have the limit is x approaching 4, and then now that expression here, let's just rewrite it. So we are going to have what? We are going to have f of 4, and then plus, and then f prime of 4 over 1 factorial, and then x minus 4 to the first power, and then we just leave it as x minus 4, and then plus f double prime of 4 over 2 factorial, and then we have x minus 4 to the second power, and then and so on. Okay, and then there was still a minus 3 here, so we still have to subtract the 3. So now that is our numerator. And then as you can see that this part highlighted in yellow is actually coming from the square root of x plus 5. Now what about the denominator? And of course the denominator is simply just x minus 4. Okay, so now we can actually start plugging in all those information that we found. And so what we can do is that we have f of 4, which is 3. So we just get the 3 here, and then plus. Now 1 factorial is just 1, so we are going to get f prime of 4, which is 1/6. So we get 1/6, and then x minus 4. And then what about this one? This one is f double prime of 4, which is negative 108. So we get negative 1/108. And then there was a 2 factorial, which is just 2. And we get 1/2 here. And then we have x minus 4 to the second power. And then just keep going plus ... And then there was still a minus 3. So don't leave out that one. Actually, let me put the brackets here so that it will be easier to read. So now that is our numerator. And then our denominator, what's going on? It's still just x minus 4. Okay. And as you can see that whether or not we put the parentheses there or the brackets there, it doesn't really matter. So you can see that there was a plus 3 here, there was a negative 3 here, so they cancel each other out as we are adding them. And then so now what really happens is that we are really just having all those terms. And all those terms will have a factor of x minus 4. This one has x minus 4 to the first power. That one has x minus 4 to the second power. And then there was the x minus 4 to the third power, fourth power, and so on, right? So now what will happen is that we can factor out the x minus 4. So if we factor out the x minus 4 over here, then we are going to just get 1/6. And then what about this thing? 2 times 108 is 216, right? So we have minus 1 over 216. And then x minus 4 to the first power, because we factor out one factor of the x minus 4 from the x minus 4 to the second power. So now it's the first power, and then there are all the terms with the x minus 4 to a higher power. And so you actually already see what's going on here. We can actually cancel out the x minus 4. Because x is approaching 4, that is really what's causing the indeterminate form. So now what really happens is that we have only the stuff inside the brackets. So we are going to have limit as x minus 4, and then we have 1 over 6, and then minus 1 over 216, and then x minus 4, and then plus all those terms with the x minus 4 to a higher power. And so now if you can see that we can directly substitute the 4 into the x, right? So all those will actually go away. And then as you can see, the only thing that doesn't have a factor x minus 4 is the first term, which is what? Which is simply just 1 over 6. And that is our final answer. Okay, so hope you like this video. Please give me a like and then also subscribe to my channel. I will see you next time.